So, welcome and thank you for joining us for another episode of the Water Connections Irrigation Series. I'm your host, Richard Restuccia, and today we're going to talk about what's upcoming, right? A little future telling, maybe, or future seeing. And the reason we're going to do this is we do talk a lot about irrigation and technology and ways we can use technology to save water. But today we're going to hit more of the point of why this is important. And one thing I've been noticing a lot in the news, and I remember 10 years ago, I could talk about the US Drought Monitor, and a lot of people didn't even know what it was. And today, people are looking at this actually a lot in the industry, which I appreciate. But sometimes I think maybe it doesn't tell a full story. So we're going to examine that and examine really where we are in connection to drought, replenishment of groundwater, and what we can do, right, to keep moving forward with our conservation message and more importantly, our conservation actions. So helping us through this today is the CEO of Orbit Irrigation, Stuart Eyring. Stuart's one of my favorite all-time guests. If you've seen him before, you know that not only is he really knowledgeable about irrigation technology and water, he's really passionate about conservation and sustainability. And that combination makes for really interesting and entertaining and very helpful for education hours. So anyway, Stuart, thank you for joining us again. Really appreciate it.
Richard, I'm so excited that you've invited me back. I'm delighted to be here and just always appreciate the opportunity to discuss topics on water. And I really appreciate the engagement that we get from those who join us. And so I'm looking forward to
that's a great point too. And I do want to remind everybody right off the bat, we've got the Q&A open. So as Stuart's going through his presentation, throw your questions in there. And for the past month or so, I've been rewarding some of the really good questions with hose end timer that is actually works off of a real-time ET. Amazing piece of technology for a faucet timer. So anyway, please chime in when you can. So Stuart, we've had this conversation a little bit about, look at that drought monitor. I'm in San Diego. It says we're actually, we're perfect. We have no drought. We have no issues. And I have a concern about this, right? Because I do know it's not quite that good. And I don't want people to relax because oftentimes this is what I see. We really conserve when we're in a drought, and when people are telling us it's not a drought, then we take our eye off the ball. We don't really conserve as much as we should. So, can you help us out and help us understand what this drought monitor is doing and saying, and how we can use that, day to day, week to week, month to month?
Yeah, what a great point. And I think these wetter years definitely make it difficult to do the job as a water conservation manager, because I do think it's so easy for people to let up on some of the gains that have been achieved. I will say, though, we have seen a continuous, steady progress in conservation overall. So we shouldn't let a wetter year completely think that it makes people's habits return to normal, because what we've seen is sustained conservation really throughout the Western United States, in spite of the fact that we've had population growth.
Yeah, and Stuart, I'm glad you mentioned that, because sometimes you think we're getting bogged down in progress, but just look at the millions and millions of smart timers Orbit's selling these days. It's really encouraging to all of us that are promoting water conservation that people are actually taking action.
Yeah, for sure. And I've got my crystal ball here. We try with these webinars, at least the ones I've been on with you, Richard, which is to really make sure that we bring something of value. And so I will be doing some prognosticating. This is used generally in the business, and so you probably see there's a lot of scratches on it. It's 20 years old at this point, but we'll try to be a little bit more scientific than that in our conversation today. We'll be using some graphs and some data. We'll be careful not to dig so deep that it gets boring, but enough that we're really dealing fact based. And I would like to just really start by saying this is the drought monitor. And I think most have probably seen it because, like Richard says, it's getting, so much really press these days. You see it fairly widely in the media, at least I know in my neck of the woods. And Richard, I thought what would be interesting is to take the last 36 months and really just see what's happened in terms of that drought map and what conditions have prevailed in different parts of the United States. And apologies, we are doing a U.S. look here, but what we're doing is generally applicable worldwide.
Yeah, that's interesting, Stuart, because you mentioned that because our first person in the Q&A is from Chile. So, but I assure you, we have plenty of people from the U.S. too.
So, sorry, it's like at Muppets 3D at Disney World. If you've been in that, Sam the Eagle to introduce the show says it's a tribute to all nations, but mostly America. And so today this is applicable though, and you'll see the points that we're talking about here absolutely are of global import and impact. So may I, Richard, go ahead and push play on this? You'll see 1 second per month. All right. So starting from this October 1st, I just took the first week of each month, starting in October 2021, and let's run it right up to today and kind of see what happens. So we were in drought then, right? At 2020, 2021, we were in really a strong Western drought. And you can see that prevailing. What you can see in the Eastern United States that the conditions were not nearly as severe, but you can see that by 2023, do you see that we're really getting drought clear in California? And then that condition persisted through much of this year. There was less irrigation being done, but look what's happened is now we get to the backside here, the now fourth quarter of 2024. We then have those drought conditions creeping back in as we look really south. Texas, New Mexico, we see really more serious drought down there. But you can see that conditions are really, I would say, favorable again for some dry conditions in 2025.
So what I was surprised at, Stuart, when you just showed that is there's, the red representing extreme drought or the maroon exceptional drought, how quickly things could change, right? We would almost go through a couple slides and we'd be really bad and then okay. But it does change pretty quickly. I'm just surprised at that, and I could see how that could really, we don't have such a big problem now, and I might relax my conservation efforts.
Right, and it's important then to understand what the drought monitor is and isn't. What it is a good representation of soil moisture and plant health conditions in natural vegetation throughout the areas that are being studied. You can see that as precipitation increases over even a short period, you see those drought conditions then change, right, to a lower status, and potentially it goes away, right, where it says none. But then you can see that it changes back again. And so really the things that the scientists who put this together are looking at are things like precipitation, stream flow, soil moisture, plant health. And there's some subjectivity to it of how long they choose to maintain certain levels in your area before they say its drought level has changed. But it is a group that shares responsibility for this using specific guidelines for how they develop it. And I think it's enormously helpful. But what it's not is an indicator of water supply. The water supply can be low even if there isn't drought. There tends to be some correlation though. Water supply does tend to be better when there's less drought because it implies that there's been rainfall, snowfall, snowpack melt. There's created stream flows or aquifer recharge that has improved the water supply, and that will show as well in the drought monitor. But
yeah, so couple questions here, Stuart. Number one, so if the drought monitor looks okay in my area, can I assume that the groundwater situation is okay?
no, no. I think to do that, there's other really helpful tools. So let me just go to the next slide. Okay, so this is for California. It's water.ca.gov, and this is the SGMA tool. And this is actually showing then groundwater measured at different locations within different aquifers. This is, a big swath of California, and so you've got a lot of different drainages in this. You've got different ways that these aquifers recharge, and they're connected in different ways. And so you can see blue is basically showing where things are above normal, down through green at the normal level, and then into the red shades where there's a groundwater deficit. So this is the better way, especially for California. And in California, you have a combination of surface water withdrawals as well as aquifer withdrawals. This is the better way to get a handle for what the groundwater levels are, is this groundwater network.
So the thing that's fascinating to me about this image here is that past 2 years in California, excessive rainfall in the winter, really heavy, in variable areas here, very close to each other. I mean, look down in Bakersfield. You have some places where the groundwater is low and not charging, and others where it's increasing, literally 50 miles from each other. I guess there's other factors that come into play here.
There are a lot of factors, including the fact that aquifers are not completely uniform. So this is super helpful for being able to go in and assess levels of groundwater and the quality of groundwater, which is also really important. Then if we move a little bit to the east, we're not going to go past the Mississippi here. So again, we've got a little bit of a constrained look, but this is the Colorado River Basin, which is really a combination primarily of streams and reservoirs. A couple of really large reservoirs that Meade and Powell, and been in the news a lot because their level dropped really precipitously in the last couple of years during this really almost decade of drought conditions. And so this is the Colorado River Basin, and it's got some unique challenges. What do you think, Richard?
Yeah, so definitely some unique challenges. And one of the things I'm really interested in is knowing if people understand where their water comes from. Because sitting down in San Diego, I always say we're at the end of the hose down here. We get a lot of our water that originally generates in Colorado. So I'd like to ask that question. Stuart, do you think very many people know where their water comes from?
I will say I do, and I encourage that everyone does. I'm up here near the Great Salt Lake, so if you see the legend box there, Great Salt Lake's just to the right of that. My water comes from a combination of my culinary water comes from a well up in Mueller Park Canyon, but my irrigation water is separate, and it comes from I believe I think I'm good on this. Out of East Canyon Reservoir down through the tunnel onto the Wasatch Front side, and then over to me. And so it's surface water on my irrigation, groundwater on my culinary.
Yeah, so that's interesting, right? And it's different for everybody almost, right? I mean, region to region. And then the other thing that people just don't understand is how much of their water costs is something I notice.
Yes, we've typically had a flat charge for our culinary or our irrigation water. I don't know how long that will continue. But then, we have tiered rates on the according to usage on the culinary water, which I think is a pretty standard practice at this point. But the Colorado Basin has upper states, lower states. There are compacts that are between all of those states. And then, of course, Mexico is very importantly included into that. But the drawdown or the overdraw of the Colorado Basin has resulted in a reduction in the amount of water that makes it to the Delta in Mexico. And so this is a super hotspot issue, and is one where a lot of research is being applied to really understand both the supply of the water, but then also the appropriation and allocation of that water, and how to strike the right balance to ensure that all the users, including making sure that the water from a terminal standpoint gets to where it should be. A lot of that is being studied and worked on. A lot of time is being spent there. Can we go a little further east? And this is the High Plains aquifer. It's got a northern piece, a central piece, a southern piece. The portion of it is the Olalla aquifer. And this is a really good study. It's the citation for it's down there on the right. I highly recommend it. It's from 2012, but a really comprehensive study. And the interesting thing that it shows is the drawdown from the 30s to 2012, 4160. This is in cubic kilometers of water. It doesn't seem significant until you look at the specific impacts in terms of areas. And this is a really interesting map here, because what it's showing is that in a relatively near time frame, where you're seeing that red, that is within presumably our lifetime, those areas will run effectively dry from acting as from being a water source. And then you can see that, by 2050, many more areas are impacted. But then interestingly, as you look at the northern part of it, not as much impact. The northern part of it can be a little misleading, because not all of that area, if you're familiar with that terrain, is farmable. And so there's water used in all those areas. But what it does say is that for the central and southern portions of the High Plains aquifer, the future is challenging. And you and I know Monty Teeter well, and he has a business called Dragonline, and it is dedicated to converting pivot sprinklers over to drip systems, which then require a much lower gallon per minute in order to run those pivots. And so it's allowing those farms, especially over in the western portion of the Central High Plains aquifer, to be able to continue farming in spite of much lower yield from the aquifer.
Yeah, very fascinating information, Stuart. And we know, right, it's been reported that in Texas, they might be losing several farms a week due to running out of water. We don't have that many people farming in the US anymore. When I hear that, it's very concerning. So this has a little bit of predictive analytics to it. One of our listeners is asking right now, do we have any data like the drought monitor that actually shows how much people are pumping, how much water is coming out of the groundwater?
Yes, and I will show that as we go. I think this is the encouraging part when we say, are we going to have a devastating drought or drastic drought in 2025? There's an encouraging piece of that, and I'll show you some of that data. I've tried on each one of these slides to also highlight sources, because some of you might be interested in going in and doing a little bit of a deeper dive for yourself. But this slide, I think, is just a little sobering, is that it just says that some of your breakfast cereal was produced with water that is not renewable in a near term, at least at the rates of today. So let's then move to my part of the world. I stare at this lake every day, and so I'm very familiar with it. And it's been in the news a lot. And I thought it'd just be kind of interesting to take a 10-year by decade snapshot for each. And we've got a story of a expanding and declining lake, and it is a salt lake. Only at the really at the east fringes of it, where you see some of that green, is you have wetland areas that are in some cases fresh, but brackish, where there's an interface between the salt water and the fresh water. But what you can see is that in 74, we were at about 4,200 feet elevation of the lake, and that's measured at the south end of it there at near the bottom at what's called the salt air gauge. The 80s were super wet in the western United States. And the Great Salt Lake is very, very flat. It's not very deep. And when you add 10 feet to it, the surface area that it covers gets a lot bigger. But a lot of that area is really shallow. And so as the precipitation decreases, you have a lot of water that's left that is, as then you've got less cloud cover, less precipitation. As the temperatures go up, it burns off, evaporates very quickly. So you see it dropping to 4,200, down to 4,196. I'm using highs here to talk about. There's about a 2 to 2.5 foot elevation change difference from the peak of the year, the spring, when all the water comes in off the mountains, to the late fall when you've had the full summer evaporated. But you can see since about 2004 to where we are today, the lake level has been pretty constant, but we put a lot of water in this year and ended up at 4192.6. So we're definitely still down. One thing I want to just highlight is that, do you see look at the 1974, the upper left, and you can sort of see the color difference between the upper part of the lake, that's called the north arm, and the lower part of the lake, the south arm. And does anybody know why that there's that difference? It's actually real. I mean, there is an actual color difference. Richard, do you know why?
Yeah, I don't. I'm interested though. It's pretty fascinating.
Yeah, and the answer is that the Union Pacific has a causeway about 20 miles long that crosses the lake, that bisects it. It has a couple of aqueducts in it, or culverts, that allow transfer of water, and that's since been expanded with this longer berm here, or bridge, and it's controllable, meaning that the state can decide to raise or lower it. During the height of the drought, they were keeping it higher to keep the salinity of the south arm of the lake lower. That helps the brine shrimp farmers. If the salinity gets too high, then you lose the brine shrimp. And so that's controllable. But today, the water is able to pass over it. But you get then kind of this pinkish color at the north arm, and then you get kind of this bluish green at the other arm. So kind of interesting there.
Yeah, very. And I wanted to say, on your previous slide, I'm actually amazed that the change from 74 to 2024 wasn't that extreme.
Well, let's look at the change over time. And this is looking at, so the low that was hit in 2020 was 4189. That was between the 2020, 2021 seasons, 4,189 feet above sea level. And I thought it'd just be interesting then to look at this graph to say, okay, since 1915, this picks January. This is an arbitrary date. It's when I happen to just grab the data. That's neither the high nor the low of the year. But this just shows the trend over time. And clearly, there is a cause of concern to say that the long-term trend is a lower elevation. But there have been periods of low elevation in the past. And I thought, Richard, it would be fun to now explore the question of, when we talk about drivers of water supply, what are they, and which ones are most impactful? And the Great Salt Lake is just a terrific way for us to get a feel for that. Sound good?
Yeah, and I definitely appreciate the slide because wow, it is showing a trend that we don't want to continue anymore.
All right. So Richard, I'm going to put you on the spot here.
Okay.
So as you look at this next slide, on the top graph, what it's showing is rainfall by year since 1915. And then the graph below it shows then the Palmer Drought Index, which actually would correspond quite closely to this. This is a long-term look at the same things that the drought monitor would capture. So it's not the same index, but it's one that if you had the drought monitor on a long-term basis, they would correspond well. So what is it, Richard, that you see in terms of possible correlation between precipitation and drought severity?
Yeah, so the first thing I get from this, right, is I'm looking at the high points on the upper graph, and they're pretty much corresponding with the bars on the bottom. So I'm thinking from looking at this that the severity index decreases or gets better with the rain and turns negative with less rain. I see a correspondence there.
You see a correspondence, but Richard, until when? There's a point on this where you start to say, well, wait, they're not matching up as well.
Right. In fact, yeah, good point. I'm seeing this now that you said that, right? The gold or yellow are getting deeper and deeper, while the highs are not getting as high.
And in 2015, you were seeing relatively normal precipitation, right? In that period, 2015 to 2020. And yet you're seeing this huge drought severity index, right? The drought becomes more severe. So let's go to the next slide and say, okay, what do we see? And again, we're just doing visual here. I've got a different, I will not bring in the the scatter plot.
Thankfully,
but with our line through it. But what do you think in terms of temperature correlation with the PDSI?
Yeah, so it looks like maybe that's the issue is we're getting higher temperatures, and one of our viewers has tipped me off and said, look, it's higher ET, right, as a result of these temperatures.
Yeah, and ET has a pretty close correspondence to open water evaporation. And so again, we're looking at a Great Salt Lake here. And now the Great Salt Lake, I have to say, is super weird because it has, in the south arm, it has between 5 and 10% dissolved solid, salt in it. And then on the north arm, the salinity can be, when it really got low here recently, it can be over 25%. Wow. And salts, the presence of salt in water changes the evaporation rate. It reduces it. But you still have, regardless, you still have evaporation. I will just say too that I like to think that the Great Salt Lake actually has a nice built-in self-defense mechanism. When people say, will the Great Salt Lake disappear? With the precipitation, so you're seeing up here, that actually, in spite of effects of warmer surface temperatures, has been relatively steady. It'd be hard for the Great Salt Lake to actually dry out because the salt concentrations get so high that your evaporation rate goes down. But I digress. Let's keep moving and just say temperatures are higher, and that is driving higher plant water use in the natural vegetation. Okay, so we're seeing less water get into the lower basin water supply because more is being used in the upper basin, right? And then it also has the impact of requiring more irrigation water. So we're seeing the continued demand from an irrigation standpoint, and then more evaporation in the lake itself. The reservoirs tend to be here, they're efficient reservoirs, deeper, and so they don't burn off as much as you'd think in evaporation. But it still is a factor. You know, there's a couple percentage point factor of evaporation in those, but the real impact comes from the Great Salt Lake. And the Great Salt Lake evaporation in a year is at its level, like it is now, is between, depending on the year, 1,700 and 2,100 acre feet. 2.1 million. I did that in 1,000 acre feet. So it's 2 million acre feet. But when it's at the high levels that it was in the late 80s, it can be 3,000. It can be 3 million acre feet. And so there's a lot of evaporation that happens on the lake, and in higher temperature conditions, you got to get a lot of water to it in order to keep it at a constant level. And that's exactly what the state of Utah and the other Bear River Compact states are working to do.
Yeah, that's interesting. Now, I want to go back to this point of ET, or evapotranspiration, right? The amount of water that evaporates out of your soil, used by the plants. As temperatures rise, they use more. But is this true about other things? Do people use more? Do we use more water in general as a result of this?
Yes, although this is where I say conservation measures are working. And so we saw when we hit really the height of the drought impact. The drought's been, we've had years and years of technical, drought, lower than average, I'd say higher than average evapotranspiration and evaporation. But we've seen people conserve more, but definitely we do see water use increase when it's not specifically constrained at a target level when the temperature is higher.
Yeah. Okay. And then one of our viewers is asking too, is this why I put salt in my pasta water to boil it at a higher temperature?
Yeah, but I went to Italy recently, and I did get a certificate of completion on a cooking course, but I think it also makes the pasta taste better. Brings it to a boil faster.
Dual purpose.
Yeah. Okay, so this is the payoff. We've gone through some, I hope not overly sciencey stuff, but just stuff that to me is really interesting. If nothing else, I hope it encourages you to think about your sources of water and what's happening upstream, what's happening downstream. But let's do now the prediction. Let's go to the National Weather Service's crystal ball here, and it's science-based. So they are predicting that there will be a La Nina, not necessarily at this point a super strong La Nina, but they think that La Nina it will emerge 60% chance and will persist through January, March. Let's look then at what that means. All right. In terms of temperatures, the expectation is that we would see below average temperatures in the north, and that we would see equal through the mid section of the U.S. and then above average temperatures as you move south. And so La Nina holding that heat south. Now, what does that mean in terms of then precipitation is associated with those cooler temps? Above average precipitation, staying above that jet stream, and then you've got the drier conditions prevailing below. And so you can see that where I sit in Utah, I always just wonder in the La Nina year how much that ski pass is going to pay off in great powder days. It's probably on balance not as good as El Nino, of course, But there still is the chance, depending on how strong that La Nina is, that precipitation drops down. And I will distinguish, I'm talking about jet stream as if this is a weather map. It's not. It is absolutely, talking about longer term weather conditions over a couple of months. But it does leave us wondering from a California and Nevada, Utah standpoint. There's a little bit of question of how much drought there would be, but it suggests that probably we won't see a drought disaster given where we're starting from. We probably just expect that we'll get some deeper shades in that drought map that we looked at earlier, drought monitor map that we looked at earlier. But probably my guess would be would not head into the deeper red that we saw in the last couple of years.
Stuart, one of our viewers is mentioning that it seems like the local conditions are turning a little bit more extreme. Do you think that's true? Has that been your experience?
Yeah, I attended. Again, I want to be careful that my credentials are in irrigation, not meteorology. But I do want to say that I attended a great National Weather Service presentation done by our local district office here. And in a very just factual way, they talked about that when you look at that temperature trend, again, it's just a science surface temperature, trend, where those are higher, that their point was simply that as the air warms and holds then more moisture in that, you do have a tendency for storms then to release more moisture in a given storm. And so there are separate, you can go out and look at them, and please, I encourage you to do this. Everything we talk about here is to spur conversation and to really get you looking deeper. But I think what you'd find is that there are trackers of storm intensity, and we are seeing those increase. And it's absolutely what you'd expect when you have warmer surface temperatures, especially in places where you've got water being carried in storm systems and then dropped. We're seeing that moisture drop with greater intensity, but not necessarily, as you can see from the graph I showed on precipitation, changing the overall amount of rainfall. Right? It's how fast and how intense it falls, not the overall quantity of it over a period of time.
Yeah, so this is interesting, Stuart. And I know you didn't know that I was going to write my blog this week about La Nina and El Nino. And I didn't know you were going to present this, but certainly this is on a lot of people's minds, right? Part of the reasons I wrote about it is people were talking, and I'm not sure, which means what. And I wanted to explain that. Do you think more people are paying attention to this today than they were 10 years ago?
I think so. And that's where I just want to highlight, and hopefully the payoff here is to really give insight into some of the amazing tools that are out there. And this is an encouragement. I didn't choose the title of the presentation, a disaster waiting to happen. But I think it's a great question. But actually, I ended, as you'll see, by saying there's a lot of encouraging work that's going on. First, these outlooks keep getting better and better. I love these. I'm always so impressed with the Bureau of Meteorology in Australia. They do phenomenal work with the weather forecasting there, and I'm sure others of our viewers can attest to the same. It continues to improve the quality of the forecasting. This is an example of the budgets. These are long-term budgets, and I'm going to highlight then first, it's terrific to have a budget. To me, I call it a statement of water flows. It says, how much am I getting of total precipitation? That includes my snowpack, everything that comes down from the upper basin into the lower basin. How much of that is used by vegetation and natural systems? That's principally going to be the loss to evapotranspiration from your natural landscape. And then you've got a basin yield from that. And effectively, you can think of that as what gets to your reservoir and storage systems or into your streams. Then you've got your depletions. You've got ag depletions, M&I is municipal and industrial depletions. And then you're going to use some of it in wetland and riparian depletion, which would include your duck clubs and your waterfowl management areas, and then some in reservoir evaporation. And then you can see, and this is great, I love this about Utah, is there's a conscientious inclusion of the Great Salt Lake to say, okay, how much should get to the Great Salt Lake? Now, I will highlight a challenge with these. The three principal inflows to the Great Salt Lake are the Bear, the Weber, and the Jordan systems. But the caveat is, you'll see it down at the bottom of the left there under the Weber Basin plan. Values based on 1961 to 1990 period are on record. And these will be updated, I'm sure, in the near future. These are getting a little bit older at this point, but they're using what's called a 30-year data set. And unfortunately, that data set is from, as we saw in our graph, right, and the first off in the Great Salt Lake elevation, a super wet period in the history of the Western United States. And the Colorado River Basin is being impacted by somewhat the same problem, is that a period of intense apportionment of water supply was being done when we had very abnormal, wet, high water supply conditions. And so the conditions that have prevailed since the 1990s have been very, very different. And so in very few years do we actually deliver this amount of water flow. So you have to keep these up to date. Is that if we look at, but probably we'd be wrong again if we took the last 30 years and used that as our planning basis going forward. I advocate for doing this on a more frequent basis using the best information that's available. That doesn't work as well for apportionments, but the reality of apportionments, and that means the adjudication and apportionment of water rights, for specific uses from specific sources in specific quantity. That has largely been done. I think we have very few in Utah developable water resources at this point. I think anywhere that's anywhere close to farming or a population center, at this point, they're closed to new appropriations. I think that's generally true throughout the United States at this point. And so it then becomes a question of how to ensure timely annual allocation of the water. And there are priorities to those, and it's a very complex process, but there is a need to recognize the fact that the stream flow and the aquifer recharge is not what was under the conditions that prevailed in the 1960s to 1990s.
Yeah, that's so interesting, sir, because what I hear you saying is we're not going to experience this disaster because we're just going to manage better. We've got the technology, we've got the interest, we just have to manage the water we have better.
I think we do. I mean, look at this for the Great Salt Lake. This is the Great Salt Lake water dashboard. There are different layers to this that show the stream flow, groundwater levels, lakes, lake levels, water quality. It's an unbelievable amount of data all about the Great Salt Lake. Is that just, it's amazing. And you can just click over each of these points. You can drill down into them, and you can see real-time conditions of snowpack at Little Cottonwood Canyon at multiple points.
Yeah, it's pretty. I've not seen this before. I can't wait till when we're done and I get to get a chance to poke around on this, because there's a lot of data there.
Yeah, it's amazing what's been put together. This is the SNOTEL network. So I was saying snowpack. We already have snowpack in Utah. In fact, Brian had a ski resort down in the south, got a couple inches of snow this early in the season. And you see that reflected. So these are actually percentages of normal. So 2,800%. So your question that you asked me earlier, I think when we were warming up, of saying, you know, is the snowpack normal? No, but it's tiny. This will, as the season goes on, these numbers will go down much closer to, you know, above or below, but 100%. So this is an example of early returns.
Yeah, I looked at it. I said, what's the date on this? This has to be last year, but
this is brand new. This is October 21st
this year, right? 150%.
Yeah. So it's tiny amounts of snow, but it just highlights again the data that's available. This then is the technology of then how water gets used, and some of you who've been with me on webinars before have seen this. Richard, you're familiar with it. But this then, from an irrigation standpoint, takes the information that's contained in the drought monitor. So it's real time. This is the map that was released this past week, October 17th. And you can see that I am, you don't know exactly where I am, but I'm to the east of the Great Salt Lake there. So I'm in Davis County. I'm in a D0 condition. You see the second ring though around D1, I will just tell you, because I know, do you see the D1 over a little bit farther east in the state? That is what will prevail in almost every year through a season in Utah. I run my irrigation controller in a drought 1 mode. That means that it takes the reference evapotranspiration, I adjust it for the specific plant type that I'm watering, and then the specific microclimate in which it's in. But I then am also applying another 10% deduction. So you can see it says drought factor 0.9. So it's 0.9 times that landscape evapotranspiration coefficient, and it's taking that down another 10%. So that's why I say I water in terms of reference ET. That's the full ET that you should never water your landscape at. But that full ET, I'm watering at 0.567 of that, because I always apply a drought D1 factor. When we got into the heavier droughts in 2021 and 2022, I was running at a D2 and at one point D4 level. And so the technology that we have allows us to adapt to the prevailing conditions.
So the reason you do this, Stuart, has to do with not watering too much or just reducing water during droughts. What's the reason to do this?
This is the way I do my part. This brings me into conformity with the conditions, is that we would expect to see in a really bad water year where we were running at a D4. That would reduce the amount of water that I would use versus the normal EPA water sense baseline. It would reduce it by 25%.
Huh.
So
wow.
Each one of those is an increment of 5, 10, 15, 20, 25% reduction. And what I found is I can run at D1, and Richard, you've seen my landscape. Right?
Yeah, I was just going to say, and how does that landscape look? And we've seen your landscape; it's fantastic. We've seen them on the webinars.
Get the irrigation components, you know, set up right, and you will find that you can really make a difference. And irrigation does in summer months account for anywhere from 50 to 70% of our water consumption, the water that does not go back into the natural system.
Stuart, we've got 2 really good questions I want to be sure we get to. And this first question is from a viewer, and it says, I noticed the Utah Agricultural Water Optimization Program is helping farmers modernize their irrigation. Have you seen any data that shows that this program is working?
Yes, and I've highlighted that before, and happy to highlight it again. Our main beehive test farm for all of our beehive ag products was able to, with technology that is, and some of that technology is, for instance, the measurement part of it, subsidized technology under that program. Subsidized meaning that there's there's incentives again toward it. And what that has allowed our test farm to do is to dramatically reduce the water consumption with yield actually going up. And then by proving the water savings, they were able to take a portion of the saved water, move it to other parts of the farm, and actually increase irrigated acreage with less water in total.
Yeah.
And then it's a super part of that program that's really, really innovative. That kind of water transfer doesn't work in every situation, but certainly the water savers incentive absolutely allows an agricultural enterprise to more efficiently use water while increasing yield. I am totally convinced.
What a great success story, and what a great example to get more government programs directed that way and more growers on these programs. So somebody else is asking about studies that have been done concerning water waste due to poorly calibrated sprinklers, poorly installed. Do you know of any of those, and what do they show?
Yes, and the studies are interesting, and what they show is, and there are many at this point, but it depends on the user. That you actually have sites that are below average in terms of how much water they use, and then there are others that are above average, and a relatively small subset is what we would say spot on from a measured standpoint. And both Richard and I, in our when we're not doing webinars, spend our time to try to get to that right amount where we say, okay, what's the objective with this landscape or with this farm, and getting to the right amount of water applied to achieve that objective. But the studies are all show that water usage is all over the place. Most people do not have a good concept on the plant water use, the evapotranspiration, and they maybe even more critically don't have an understanding of how much water they're applying zone by zone, area by area. And so that's the thing that the studies has shown, is that the precision application combined with the smart control helps get the water usage right.
Yeah, that's right, and that's the whole key, right? Is getting it right. Be more efficient about the water we're using.
Yeah, and I'm going to show one more thing that will expand on, that will really give what I think is the right answer to that question, because the studies aren't getting at something that I'd like us to get to. So I'll get to that. Give me the other question though, please.
Yeah. So that no, that was the question.
All right. Perfect. This then is an example of technology applied. You can see that this is an October schedule. This is mine. I won't actually water. We had a very warm October. So when Richard asked me earlier about the leaf change, we won't get a good leaf change because we didn't have a cool down in the temps. We just started to basically, lose the leaf color without them turning vibrant color. I watered a couple of times at the beginning of the year. I let it, or the month. I then let it go. Watered last on the 14th. We had rainfall last week. My water is off at this point, but it would, on a smart basis, choose to water on the 27th. This, though, is an example of, yes, I could turn the water off on October 1st. My home is a test site. I test every aspect of our beehive control. And the example that I would just use here is I've let this run naturally, the way it would run, saying, okay, I'm going to factor in the temperature, the humidity, the wind, the rain, the precipitation, and solar radiation, and then I'm going to make those adjustments. And this is what that schedule would look like. You can then see that the accounting is being done for every zone of saying, okay, where on any given day, this is looking at yesterday, is that moisture balance starting out in that soil. How much will it draw down? And you can see it only from an ET standpoint. This is adjusted ET, right? Specific for my landscape. Only dropped about 0.06 inches. And so I left it's leaving it at 0.19. So I've got, you can see days left plus precipitation coming up where I wouldn't need to water again until the 27th. Again, my water's off at this point, but this is just showing what the flow of that irrigation schedule would look like. And then on the far right, you can see my usage, and you can see again, I just let it go. I started 2023 in a more serious drought mode. I put it to a D1 for 2024, and yes, my usage went up 3%. The difference in days watered is I had a grow-in period for some more water-wise plantings that I put in at the end of 2023. Let's then go to, and Richard, this is the takeaway, and I know we're getting to the end of time here, not in terms of the world, but of our webinar, together. And what I want to just highlight here is look at the data we have available. And this is to the joy and the frustration of every water department in a state where water is an issue. And I say water department, but by that a water resource planning department looks at a division, looks at this and says, wait, we know our snowpack and precipitation. We know our reservoir levels and our stream flow. We know our evapotranspiration. They will tell you certainly here is that we don't know. There are different data sets being created to do open water ET, but evaporation, for instance, on the Great Salt Lake is not where we'd like it to be. The old funding for the pans, we have technology today that can replace the pans, but it hasn't been implemented yet. And so I think that's one area where we'd say, we're not quite happy where we are with the evaporation data. And that's super important to understand from those critical, lakes, reservoirs, and the Great Salt Lake. What is the actual evaporation off of that? Recognizing the Great Salt Lake south arm is going to be very different than the north arm, and the west side by the desert is going to be very different than the east side by the benchland. Groundwater measurement, we saw a really good job there. And diversion in the return flow measurement, pretty good. There's still some more measurement that we could put in there, understanding wetlands better and their usage and the flow, the return flow from them. A little bit of opportunity to work there, but all of this is being worked on. Everything I've mentioned are areas where it's either in place or it's being worked on. The water right apportionment is being worked on as well. The Division of Water Rights here in Utah is working on that piece of it. They're working to put all of this data, and this is the next step, into an integrated data lake. And whether it's the Colorado River Basin, and of course you've got upper, you've got lower, you've got different sections of that, or the Great Salt Lake, or whether you're talking about the High Plains, aquifers and its divisions. The data is being put together. Studies are being done that are helping understand the movement of water through those aquifers and across those drainage basins in more real world ways that factor in, the changes we're seeing in surface temperatures and types of precipitation. And that is all of that work is being done. And the effort is to then put it into the integrated data lake, which then allows us to put together on a more time-specific basis, not just long-term, but to sort of say, okay, annually, what's our water flow budget? What then is our water right allocation? How do we deliver water in a smart way? And that's where the incentives come into play, is you can say, okay, put technology in that allows the water to be then used, consumed according to that allocation, and then to generate a water flow report that says, how did we do? And we're really, really close to being able to do this. You can imagine that part of it is native intelligence, but part of it is artificial intelligence as well to do this. And so when we ask the question, Richard, and this is the takeaway, is a drought disaster waiting to happen? I say it is an opportunity to use data and analytics to improve, and that is happening real time. So I sit here today saying, I'm very optimistic about our ability to use the tools and the analytics at our disposal, the measurement devices that we're putting in, and the control devices to be able to get a really, really good handle on water supply and demand in a way where we can satisfy not just the human users in the equation, but that we can also make sure that the natural systems in terms of drawdown and maintaining lake levels, that those users are protected as well.
Yeah, wow, Stuart, I too am optimistic after watching this now. And we're a long ways from estimated water use because we haven't been measuring it to that chart you just saw us, or that showed us that diagram a few seconds ago. This is very encouraging, and I want to say thank you for putting this together. Boy, I'm coming away feeling better about things by a whole lot. So thank you for doing that.
Richard, thank you. I appreciate the opportunity to really have this conversation. I know we'll need to end the webinar. We've hit time. Was there any other question, Richard, that is out there?
Yep, no, we've got them. So thank you to our viewers for the great questions, for spending some of your busy day with us, learning about conservation and sustainability. We really appreciate that. To all of you who have missed some of our webinars or want to review them, remember you can see them all for free at hydrarain.com/webinars, and anywhere that you listen to your favorite podcast, right? I love it that people are out there working, listening on their earbuds, and learning about conservation and sustainability by listening to our podcast too. So thank you to the viewers. Thank you, Stuart. I really appreciate it. Hopefully we'll see most of you at the Irrigation Association show here the first week in November in a couple of weeks. Looking forward to that. And thanks again.
Thank you.
Bye, Stuart.